In February 2025, a number appeared on a NASA risk table that hadn't been seen in nearly 2 decades. Not a small, reassuring decimal buried in the footnotes. A number large enough that international space agencies activated formal emergency protocols. A number that meant, for a brief and genuinely tense stretch of time, that a newly discovered asteroid had a real, non-trivial chance of hitting Earth. Scientists didn't want to see that number. Nobody did. Planetary defense teams around the world had spent decades building systems specifically designed to catch a threat like this early, and now, for the first time in years, one of those systems had actually flagged something worth taking seriously. And over the following year, the James Webb Space Telescope became the single most important tool in figuring out exactly what that number actually meant, and whether the threat was real. This is the story of asteroid 2024 YR4, how it briefly became the most dangerous object ever tracked heading toward Earth, how the danger shifted rather than disappeared, and how Webb ultimately settled the question using some of the most precise measurements ever taken of a small, distant space rock. Let's start at the beginning. On December 27, 2024, an automated survey telescope in Chile, part of the same Atlas network that has caught several major discoveries in recent years, spotted a faint object moving against the background stars. Astronomers calculated its orbit and immediately flagged it for follow-up. The object, designated 2024 YR4, was estimated to be somewhere between 40 and 90 meters wide, roughly the size of a 10-story building. Not large enough to threaten civilization globally, but large enough that a direct hit on a populated area could level a city, flattening buildings across dozens of square miles, depending on the angle and speed of impact. As more observations came in through January 2025, something happened that unsettled the entire planetary defense community. The impact probability didn't shrink the way it normally does as more data arrives. It grew. Astronomers watched the number climb week after week, an unusual and uncomfortable pattern that meant the object's true path was still stubbornly hard to pin down. By February 2025, NASA's risk assessment put the odds of 2024 YR4 striking Earth on December 22, 2032 at roughly 3.1%. To put that number in context, it was the highest impact probability ever recorded for an object of its size, and it briefly pushed the asteroid to a level 3 on the 10-point Torino impact hazard scale, a rating that had only been reached by a handful of objects in the history of the scale, and one that officially calls for close monitoring and public attention from astronomers and the public alike. For a few weeks, headlines around the world ran with it. Was this the one? Was this the asteroid scientists had spent decades of planetary defense planning preparing for? The European Space Agency and NASA both issued public statements, careful to stress that the risk, while real, was still far more likely to resolve into a safe miss than an actual impact. But for the astronomers actually running the numbers, the uncertainty itself was the uncomfortable part. Nobody could yet say for certain which outcome it would be. Social media filled with speculation, some of it wildly overblown, some of it genuinely well-informed, and for a brief moment, an object most people had never heard of a month earlier became one of the most talked about topics in science news anywhere in the world. Here's the part that separates real science from the panic that often surrounds it. That rising probability wasn't a sign the situation was actually getting worse. It was a sign scientists still didn't have enough data. Early in the tracking of any newly discovered object, the range of possible future positions is wide, and Earth sometimes sits uncomfortably inside that range simply because the range itself hasn't been narrowed down yet. Picture it like a wide, blurry smear of possible landing spots on a map, with Earth sitting somewhere inside that smear. As more precise measurements come in, that smear typically shrinks, and when it shrinks, Earth either stays inside the narrowing range, which is genuinely bad news, or falls outside of it entirely, which is what almost always happens. By late February 2025, with more ground-based observations added to the model, the odds of a direct Earth impact dropped sharply. And in an official update, NASA formally reduced the Earth impact risk to a level considered no longer significant. Astronomers describe this shift not as luck, but as exactly the outcome the process was designed to produce. The uncertainty had been genuine. The resolution was earned through data, not assumption. Even so, the episode left a lasting impression on the planetary defense community, a reminder that the gap between possible and probable can look identical to the public for weeks at a time, even when scientists behind the scenes are watching the numbers move in a clearly reassuring direction. Earth, it turned out, was safe, but the story didn't end there, because as scientists refined the asteroid's path, they noticed something else, a newly narrowed trajectory that put a very different target inside the range of possible outcomes: the Moon. This is where the James Webb Space Telescope entered the story directly. In March 2025, Webb observed 2024 YR4 using its near-infrared camera and, for the first time, precisely measured the asteroid's actual size using thermal infrared data rather than estimates based on brightness alone. Ground-based telescopes can only estimate an asteroid's size by how much reflected sunlight they detect, a method that leaves real uncertainty since a small, highly reflective rock can look identical to a larger, darker one. Webb's infrared instruments instead measure the heat. The asteroid radiates directly, giving scientists a far more reliable read on its actual physical size. The result? Roughly 60 meters across a building-sized rock, confirmed with far greater confidence than ground-based telescopes could achieve. That same observation run gave scientists a clearer read on the asteroid's orbit. And by June 2025, using one final Webb observation, captured just before the asteroid became too faint and distant to track from Earth at all, researchers refined the 2032 close approach prediction significantly. The result surprised almost everyone tracking the story. The chance of a lunar impact had actually risen from 3.8% to 4.3%. For the next several months, that was where things stood. 2024 YR4 was headed away from Earth, moving through a stretch of its orbit where no telescope, space-based or 4.3% chance of a lunar impact in December 2032, and years of waiting before new data could resolve the question one way or the other. Except Webb wasn't finished. In February 2026, an international team led by Andy Rivkin at the Johns Hopkins Applied Physics Laboratory and Julian DeWitt at MIT requested emergency directors discretionary time on the James Webb Space Telescope, a rarely used allocation reserved for genuinely urgent science that can't wait for the normal scheduling process. Their plan was ambitious. Catch 2024 YR4 during two narrow observing windows on February 18th and February 26th, 2026, timed specifically to moments when the asteroid would pass close to stars already mapped with extreme precision by the European Space Agency's Gaia satellite. By using those well-known stars as fixed reference points in the same image, the team could measure the asteroid's exact position with far more accuracy than a standalone observation ever could, essentially using the known stars as a ruler to pin down exactly where the much fainter asteroid actually was. It worked. The February 2026 observations represent the faintest confirmed detection of a near-Earth object ever achieved, and they nearly doubled the total length of time 2024 YR4 had been tracked, stretching the observational baseline from roughly a year to closer to 2. That extended baseline let orbital dynamicists narrow the asteroid's predicted position on December 22, 2032, by roughly a factor of 12, collapsing what had been a wide band of uncertainty down to a tight, confident line. The result, announced in March 2026, the Moon is safe. 2024 YR4 is now projected to pass by the lunar surface at a distance of about 13,200 miles, more than 21,000 kilometers, with the possibility of impact fully ruled out. Not reduced, ruled out. So what actually happened here, from start to finish? An object briefly carried the highest impact probability ever assigned to a near-Earth asteroid of its size. That risk was real, taken seriously, and resolved responsibly, exactly the way planetary defense is supposed to work. Not through guesswork or reassurance, but through steadily accumulating better data until the uncertainty collapses into a confident answer. It's worth noting that the entire arc, from initial discovery to final resolution, played out in roughly 14 months, a genuinely fast turnaround for a question this consequential, and one that would have taken considerably longer without a telescope capable of tracking the asteroid long after it faded from every other instrument's view. And this is precisely why scientists say the story matters even now, with the danger fully cleared. Because it proved, in a live, high-stakes situation, that Webb can function as a genuine planetary defense instrument, not just a tool for photographing distant galaxies and newborn stars. Rivkin and DeWitt's team noted that without Webb's involvement, researchers would have had no choice but to wait until 2028, when the asteroid becomes observable again from Earth, carrying years of unresolved uncertainty the entire time. Years in which the public, the media, and planetary defense agencies would have simply had to sit with an open, unanswered risk hanging over a specific date on the calendar. Webb's extraordinary sensitivity let scientists detect and precisely track an object far too faint for any ground-based telescope to see, essentially buying years of certainty that would otherwise have simply had to be endured. That capability matters far beyond this one asteroid. Small, dim, near-Earth objects like 2024 YR4 are discovered regularly, sometimes dozens in a single year, and most of them fade from view within weeks of being spotted, long before their full orbital risk can be properly assessed using ground-based instruments alone. Webb's demonstrated ability to track an object this faint, this far away, and refine its future position. This precisely gives planetary defense scientists a genuinely new tool, one capable of resolving exactly the kind of nerve-wracking uncertainty that made headlines throughout 2025 far faster than waiting for an object to swing back into view years later. 2024, YR4, will make its next close approach to Earth in 2028, when ground-based telescopes will finally be able to observe it directly again, adding yet another data point to an already remarkably precise trajectory. Scientists don't expect any surprises, but if this past year proved anything, it's that the process of ruling out a threat, carefully, transparently, and in public view, is exactly what responsible science is supposed to look like, even when the numbers along the way are the kind that nobody wants to see. It's also worth remembering just how young this entire capability is. A decade ago, no instrument on Earth or in space could have tracked an object this faint, this far from the sun, with this level of precision. The fact that Webb, a telescope originally designed to study the earliest galaxies in the universe, turned out to double as one of humanity's most capable planetary defense tools is not something anyone planned for when the observatory was first proposed. It's simply what happens when you build an instrument sensitive enough to see almost anything and then point it at something that actually matters. If you want to know the moment Webb catches the next object like this one, subscribe and turn on notifications, because somewhere out there, the next 2024 YR4 is already waiting to be found, and when it is, this channel will be watching the numbers as closely as the scientists are.